In this video, we're going to look at the regression line x on y. We've already looked at the regression line y on x, where we use the equation of our regression line to calculate the value of our dependent variable if we know our independent variable. So if we look at this table, we've got the table below shows the hours spent by Maths 2020 students studying the night before their test and their test scores. So our x values are the number of hours studied, and they range from 1 to 6. Our y values are our test scores, and they range from 65 up to 95. If we drew this on a scatter diagram and then equated the regression line, we would be able to use the equation for the regression line to calculate a test score knowing the number of hours studied. We couldn't use our regression line equation to go the other way. In other words, we couldn't input a test score and output the hours studied. This is because the way the regression line or line of best fit is calculated when it is drawn on a calculator. The first thing I'm going to do is draw a regression line and a correlation diagram that fits this set of data. I've opened my TI Inspire in a lists and spreadsheet. I've already input my data. Into column A I've put the hours, and into column B I've put the scores. Now I'm going to open a separate page. I want a data and statistics page, and if you can see, all my data suddenly appears, but it's very random. So now I'm going to tell the calculator what to do. So on my x values, I want it to be hours, and my y values to be score. And there you go, it draws me a nice scatter diagram illustrating my data. Right, I can also get it to draw a line of best fit. So if I go to Menu, Analyze, go to Regression, and I want to show linear mx plus b. And there you go. I have got my line of best fit, my regression line. And the equation of that line is y equals 5.25941x plus 64.3661. But if I want my regression line of x on y, all I need to do is switch my variables around. So I would put score on the x-axis and hours on the y-axis. So let's do that. So I'm going to go for score. So it switches it round automatically, and that gives me a regression line of y equals 0.167132x minus 10.3221. So those are two totally different regression lines. So I'm going to take a screenshot of both of these regression lines so I can use them later on. I'm going to take a closer look at the two regression lines that we just calculated and look at the screenshots and explain to you how a regression line is actually calculated. Here are screenshots of my two regression lines as taken from the TI Inspire. Right, what is happening when we are calculating a regression line? So there's my original hours against scores, and what it is actually doing, it is taking all the horizontal distances from each of the points to the line of best fit, and it wants to make the average of those the smallest. When it is doing an X on Y regression line, it is taking, let's change colours, it is taking the horizontal distance from each point to the line. And so it will give you two different lines. The equation to find the score given the hours is y equals 5.25941x plus 64.3661, and the equation to find the hours given the score is y equals 0.167132x minus 10.3221. That should really be written as x equals 0.167132y minus 10.3221. That is because the TI Inspire is not capable of switching the two variables around. It actually now thinks y is x and x is y, but technically our x on y equation is this one here. So if I want to answer these two questions, A, calculate the equation of the regression line x on y. So my regression line should be written as x equals 0.167y minus 10.3, and that's everything to three significant figures. B, use the regression line equated in A to calculate the hours studied of a student obtaining a score of 75 in her maths test. So we use the equation x equals 0.167y minus 10.3, substituting 75 for y, so x equals 0.167 times 75 minus 10.3, and if you equate that on your calculator you get x equals 2.23 hours, which is very consistent with our data.